A ladder is sliding down a wall right now, and calculus can tell you exactly how fast the top is falling. Here is the setup. A 10-foot ladder leans against a wall, the bottom is 6 feet from the wall, and it is sliding away at 2 feet per second. Let x be the distance from the wall to the bottom of the ladder, and let y be the height of the top of the ladder up the wall. Since the ladder has a fixed length of 10 feet, the wall, the ground, and the ladder form a right triangle at every instant. So, by the Pythagorean theorem, x squared plus y squared equals 100. Now we differentiate both sides with respect to time, t, since x and y are both changing as the ladder slides. Differentiating gives us 2x times dx by dt plus 2y times dy by dt equals 0. We need the height, y, at this exact instant. Since x equals 6 and x squared plus y squared equals 100, we solve and get y equals 8. Now we substitute in the known values, x equals 6, dx by dt equals 2, and y equals 8, into our differentiated equation. This gives us 2 times 6 times 2 plus 2 times 8 times dy by dt equals 0. That simplifies to 12 times 2 plus 16 times dy by dt equals 0. Solving for dy by dt, 16 times dy by dt equals negative 24, so dy by dt equals negative 1.5 feet per second. Let's check this. The value is negative, and that negative sign tells us y is decreasing, meaning the top of the ladder is falling. That matches exactly what we see in the picture. As the bottom slides out, the top slides down.